Alright guys, in this playlist I'm going to go through acids and bases. This is one of my favourite chapters, but I know it's quite hard, so I'm going to try to break everything down slowly. Make sure to like and subscribe and comment down below what topic you guys want me to go through next. Alright, so firstly there's a couple of definitions that you guys need to know. So an acid is called a proton donor, and this can be explained through the example that we have here. So we have hydrochloric acid, and it dissociates to H plus and Cl minus. Now H plus is basically just a proton. So essentially this acid just donated a proton by splitting or dissociating, which is the word they normally use. Now a base is a proton acceptor. So these combine with H plus to get rid of the H pluses in the solution. You also need to know what's meant by the strength of an acid. So strong acids dissociate fully to form H plus ions, whereas weak acids dissociate partially to form H plus ions. Now in an exam they might also ask you what's meant by a strong base or a weak base. It's basically the same definition, however instead of H plus ions, it's OH minus ions. Okay, I've copied down this table here because I think it's a really good summary of everything that you need to know. So to begin with, the weak acids are normally carboxylic acids, and they normally end with oic. Now the reason that these are weak is because the equilibrium is mainly to the left. Therefore, there's a high concentration of this and a low concentration of this. So essentially, the acid barely dissociates to form H plus ions, just like a weak acid does. Now, for strong acids, all you need to really remember is that most of the time it's going to be any other acid apart from carboxylic acids. So hydrochloric, sulfuric, nitric. Just remember, if it's not a carboxylic acid, it's probably a strong acid. Now for these, the equilibrium is mainly to the right. So much so that this reaction you wouldn't even consider it as an equilibrium. It's basically just a forward normal reaction. This means that the hydrochloric acid fully dissociates in water. So essentially, there's basically a concentration of 0 after the reaction is completed. Whereas H plus, there's going to be a high concentration. So the acid fully dissociates to form H plus, just like a strong acid does. Now a strong base is basically any base with a OH minus ion, like this. Now these are basically similarly in this forward direction, like this. And this is because these are ionic compounds. So when you put an ionic compound in water, they split very easily or dissociate very easily. And this means there's going to be a high concentration of OH minus ions. And basically a concentration of 0 for the NaOH once the reaction is fully completed. Now a weak base is basically any type of base with a nitrogen most of the time. These reactions are in equilibrium, mainly to the left though, and this means there's going to be a high concentration, and this means there's going to be a low concentration of OH minus ions and high concentrations of the base. Alright, so that's essentially the basics of what you need to know. Okay, now from GCSE you might remember the term pH. P is basically the same thing as minus log. So whenever you see a small p like this, it just means minus log. Whatever's next to the p is what you put inside the log. So for example, if you see pH, there's a H next to the p, so that's what you put inside the log. So you put a H plus concentration. Okay, these are meant to be square brackets. Now if they ask you for the definition of pH, you can literally write in your exam minus log H plus, but make sure to use square brackets. And it's the same thing with POH. It's the minus log of OH minus ions, but the concentration. Now what pH actually is just a way of comparing the concentration of H plus ions of different solutions without having to say very long numbers. Now what pH actually is just a way of comparing the concentrations of H plus ions of different solutions without having to say very long numbers. Okay, so imagine you had two different solutions. One has a hydrogen concentration of 0.000354 and the other one has a hydrogen concentration of 0.0001. 178. Okay. Then you want to compare these hydrogen concentrations. Instead of saying all of these numbers, if you minus log it, it makes the numbers more manageable. Because what minus log does is it makes the numbers between, usually somewhere between 1 and 14. And this is a really nice range to work with because the numbers are just better instead of saying these long numbers like this. Alright, so for your exams, you also need to be able to calculate the pH of a strong acid. So we use the fact that a strong acid fully dissociates in water. Now, what this means is that if we have originally 1 mole of hydrochloric acid, then in this ratio, there's going to be 1 mole of H plus ions. Okay? So since it's a 1-to-1 ratio, the moles of H plus is the same as HCl. Therefore, the concentration of H plus is the same as HCl. Now, before we said that the pH is minus log H plus. Okay? But we just said that the concentration of H plus is the same as the concentration of hydrochloric acid. So, we can say that the pH is also equal to minus log HCl. Okay, I'm just going to put square brackets here as well. Okay, it's very important to remember you can't use normal brackets for concentration. Now for diprotic acids, you also need to factor in the molar ratio. Alright, I made some examples for us to try. I'm going to go through the first one. So initially we have hydrochloric acid, and we know that's going to dissociate to H plus and Cl minus. Alright, so initially our concentration of hydrochloric acid is 0.5 moles per decimeter. And since it's a 1-to-1 ratio, our concentration of H plus is also going to be 0.5. And now we can just do minus log of H plus to get the pH. And we get 0.30. Okay, now have a go at the rest of them. Pause the video, try them, and play to see the answers. Okay, now hydrobromic acid is quite similar. So we have HBr, and then we form H plus and Br minus, right? So initially we have 0.23 moles per decimeter of hydrobromic acid. This means we're going to have 0.23 moles per decimeter of H plus ions. This is because it's a 1-to-1 ratio. And now we can just minus log 0.23 to get 0.64. Now for sulfuric acid, we have H2SO4, and this dissociates to 2H plus and SO4 minus. Now, we originally have 0.1 moles per decimeter. However, sulfuric acid to H plus is a 1-to-2 ratio. So this means if we want to work out the H plus concentration, we need to times it by 2, so that we get 0.2. Then we can just minus log this. Alright? Now, nitric acid has the formula HNO3, and this dissociates to H plus and NO3 minus. Now, originally we have 0.2 moles per decimeter of nitric acid, so that means we have 0.2 moles per decimeter of H plus ions, and now we can just minus log this and we get, okay? Now, the formula of phosphoric acid is H3PO4, and this dissociates to 3H plus and PO4 3 minus. So originally the concentration is 0.15. Now phosphoric acid and H plus is a ratio of 1-to-3. So we're going to times 0.15 by 3 to get 0.45. And now we can just minus log this to get 0.35. Now the reason why all of these pHs are so low is because they're strong acids. Okay? And strong acids normally have a really low pH. Also, I think it's really useful to memorize the formulas of all these acids. So hydrochloric acid is HCl, hydrobromic acid is HBr, sulfuric acid is H2SO4, nitric acid is HNO3, phosphoric acid is H3PO4. Okay?